Hey students, we're starting a new unit. We're starting the similar figures unit. This is going to be a very short unit, so expect a quick turnaround for a test. We're going to move quickly. Stay on top of things, watch your videos, make sure that you watch your videos on time. All right, so you have your notes. You also need your vocab and you need 4 highlighters. I'm going to go ahead and go over the vocab. These are the vocab words that I'm covering, and they are on page 29. Okay, so some of this goes back to some very basic math. First of all, a ratio is a comparison of two numbers by division. A ratio can basically be written as a fraction. This is not a proportion. This is just showing you it can be written as a fraction. It does have to be reduced. So I could not put 3 to 6 this way or 3 to 6 this way because it wouldn't be reduced. No matter which of these 3 ways you write it, as a fraction, circle that, as 2 numbers with a colon between them or 2 numbers with the word 2 between them. It doesn't matter. It just simply has to be reduced. Sometimes I like writing scale factors like this, but if you write it like this, we have the same answers. No big deal. Okay, then we have proportions. A lot of your work in this unit are going to be solved by doing proportions, and we will be solving proportions. We will be cross multiplying. You may not have ever heard of these words, I'm not sure, but when you have a proportion, you have what's called the means and extremes. As we go through and work the problems in future worksheets, you're going to see that if I have the problem set up differently than you, we could still get the same answer because we're multiplying the means and the extremes. Okay, so if you have a proportion, which is 2 ratios put together, the means I've got in pink are these 2 terms here. The extremes are these 2 terms here. And it's easier to see if I write this problem using the colon. So watch what happens. Okay, so if I write it this way, the means are in the middle. If this ever shows up anywhere, the means are in the middle. The extremes are on, oh, I just did that backwards. I am so sorry. I'm going to change that to pink. The means are in the middle. Put a big pink over that. Big mistake. And the extremes are on the ends. Okay, there we go. The means, which are pink. So sorry for that. Let's write that a little bit darker. There we go. All right, the means are in the middle, the extremes are on the ends. And so when you're doing a problem, you could actually, when you see how we learn to set these up, I could actually say like 3 over x equals 4 over 56 minus x. And when that's set up, we're still multiplying the means and extremes. So the actual definition is a little confusing, but it is an equation that states 2 ratios are equal. That's a proportion. The means are the second and third term or the middle. The extremes are the first and fourth term or the edge. Extreme is the edge, mean is the middle. Okay, so this is the middle of the problem. This is the edge of the problem because that's where we end, that's where we start. Okay, similar figures. This is the big deal. Similar figures are figures that have the same shape but not the same size. We briefly covered dilations in the unit with the transformations, and we learned that dilations do have a scale factor, and there's 2 things that go with similar figures, and you are required to know these. All right, so make sure you know these because this defines similar figures. The corresponding angles are going to be congruent. So if this angle is 100 degrees, then this angle is also 100 degrees because those are the corresponding angles. When I say corresponding, I'm not talking about corresponding in parallel lines. I'm saying the angles that would map on top of each other. If this angle was 21 degrees, then this angle would be 21 degrees. That figure would slide perfectly into that angle. Even though it's smaller, the angles still fit perfectly. The corresponding sides are proportional. So that means there is a scale factor. And we look at the numbers, like if this was 10 and this was 8, then I could get the scale factor from making a fraction out of the 10 and the 8, which we're going to see that over here. And that would be 5 to 2. So the scale factor would be 5 to 2, written like this. Okay, and I write it like this or this, either way. Okay, so similar figures. Corresponding angles are congruent. Corresponding sides are proportional, meaning I can get a scale factor. Okay, so the scale factor is taken from the ratio between two corresponding sides of figures. The way we get which sides go with what is we always put the smallest with the smallest, largest with the largest, the middle with the middle, and so on. So I knew that the 2 goes with the 5 because this is the smallest on this triangle. This is the smallest on this triangle. The 4 goes with the 10 because that's the middle number. This is the middle number. 6 goes with the 15 because it is the biggest number. Do not always go with the bottom goes with the bottom or the right goes with the right, because this triangle can be flipped. And if that was so, the 10 would be here, the 5 would be here. You have to match up the corresponding pieces. This is how we get the corresponding pieces, except when a similarity statement is given to us. And so you're going to see things like triangle ABC is similar to triangle DEF. And when you see that, then you are going to know which pieces go together by their placement, just like we had with congruence. AB would be proportional to DE. You could get a scale factor by putting these two pieces together. Or BC and EF, you could get a scale factor by putting those two pieces together. Angle A should be equal to angle D. Angle C should be equal to angle F, and so on. All right, done with vocab. Go to your notes. Okay, we have 6 examples to go through, and you're going to get a lot of information out of these examples. I like to teach similarity using highlighters. So it's pretty easy to see what corresponds to what in this picture. Number 1, we have angles marked. Number 2, it is a trapezoid figure. So we can kind of tell by the orientation of it what it is. It's harder to do that with triangles, so be very careful. But I'm going to go ahead and throw some color on here, highlighting the corresponding pieces. Because I like to tell my students, if you use highlighters, then these ratios right here are just green over green or pink over pink, yellow over yellow, orange over orange, and it's real easy to keep that up, to keep track of it. So this is orange over orange. If you see this, it's going to be 8 over 6, and 8 over 6 reduces to 4 over 3. The way I would know if these are similar is if all of these equal 4 over 3. So let's check that. HJ is pink, so I'm going to say HJ over MN is 20 over 15. And 5 goes into both of those, and it gives us 4 over 3. GH is yellow, so 16 over 12. And 4 goes into both of those. So far, so good. And then FJ is green, so that would be 12 over 9. And that does reduce to 4 thirds. So this is similar. We would say, yes, it is similar. All of the angles correspond. They are equal to each other. All of the sides are proportional in the fact that they have the same scale factor. So the two figures are similar, and you can write a similarity statement. Now, it doesn't matter how I name the one on the left. The one on the left will go here. The one on the right will go here. If it was a shape where it was top and bottom, this would be the shape on the top. The shape on the bottom would go here. It doesn't matter how I start off writing this, as long as I make the other one match up. So I'm just going to go in letter order, F, G, H, J. And I know F, G, H, J, I went, and it's really easy with the colors, I went orange, yellow, pink, green. F, G, H, J. Orange, yellow, pink, green. So I'm going to follow the same pattern, and I'm going to say K, L, M, N. And we had enough practice with this before that you guys know that it has to be in the same order. This is a great life statement. It doesn't matter how you start, it matters how you finish. It doesn't matter how I write this down, but the one that I finish with has to match it. Okay, next example. The two figures are similar, so they tell us it's similar. Complete the similarity ratios and find the missing angles. So angle R, first of all, let's match up things. I know that RQ is 12. It is, well, I know the hypotenuse goes with the hypotenuse. We can get that right away. Okay. And then RQ is with the 37 and the right angle, and the 37 and the right angle is down here. So you can see how that figure is rotated. You have to be really careful. And then those go together. I could also say between 12 and 9, 12 is the bigger number. Between 8 and 6, 8 is the bigger number. Biggest with biggest, middle with middle, biggest with biggest actually is green. Biggest with biggest, smallest with smallest, middle with middle. Okay, angle R corresponds to angle K. They are congruent. Angle S corresponds to angle J. They are congruent. And angle Q corresponds to angle L. They are congruent. And I could tell that by the number here, the number here. Those angles have to be congruent to each other. Also be careful. They may give you like the 37 here, and they might give you the complement here, and you would have to find all the angle measures to make sure they're congruent. And then setting up our proportions, RS is orange, so it goes with JK. RQ is pink, so it goes with KL. Actually, this one should, I'm going to write it correctly just to be consistent. Let's try to put it in the right order. R is at the right angle, and K is at the right angle, so we really should put KJ to be accurate. And then SQ, SQ is the hypotenuse. SQ goes from orange to pink, so we have to follow with JL. And then down here it says circle which is the correct similarity statement, circle which one you think is correct. That's going to be our first answer to our question. Which one of those similarity statements do you think is correct? All right, you should have got that the middle one is correct. It has the letters matching perfectly with the colors and the angles that are marked in the picture. Okay, next example, number 3. First of all, we're going to verify that the two triangles are similar. Write a similarity statement, find the ratio of their perimeters. We haven't talked about the perimeters yet. Let's go back up here. All right, take a minute and find the perimeter of this figure and the perimeter of that figure and write them on the inside. Go ahead and do that now. All right, you should have got 56 for the perimeter of this one. I just asked that question just to make sure you were doing it. And the perimeter of this one is 42. Well, guess what? When you have similar figures, their perimeters are also proportional. So that means that the perimeters will give you the same scale factor. So if I put 56 over 42, and I reduce that, what goes into 56 and 42? Okay, well, I know 7 goes into both of these. 7 times 8 is 56. 7 times 6 is 42. And then that reduces to 4 over 3. And so the perimeters are proportional. Let's write that down. Perimeters are proportional, meaning they give the same scale factor. Okay, and also remember, you can be writing that scale factor like that or as a fraction, either way. So when we come down here, we are going to have to write the perimeters. Often I will put the perimeters inside the triangles. Okay, so first of all, to verify the two triangles are similar, we would have the same scale factor. So we're going to have to find what goes with what. Okay, so in this picture, 15 is the biggest, and over here, 10 is the biggest. You know, this kind of looks like number 2, doesn't it? Yes. So let's get these marked accordingly, and it's going to be exactly like number 2. The 8 goes with the 12, and then the 9 goes with the 6. Okay. So if I was going to verify, I do have angles that are congruent. This is between the green and yellow. This is between the green and yellow. This is between the green and pink. This is between the green and pink. Third angle theorem says these angles are automatically congruent as well. So all the angles are congruent. And because we checked this up here and I knew this was similar, I know these are going to work. But I just want to show you that if I put 15 over 10 and then 9 over 6 and then 12 over 8, okay, and I check all of this, all of these are going to reduce to 3 over 2. Okay. Make this easier. Work smarter, not harder. There we go. They all reduce to 3 over 2. So that tells me because all of the angles are congruent and the sides are proportional, these figures are similar. Okay, so we have verified it. Write a similarity statement. So I'm going to say triangle. Remember, it doesn't matter how I start this one. If I go triangle RPQ, I just randomly pick the letters. RPQ, RPQ. So I went yellow, green. I have to follow the same thing here. Yellow, green. SVT. And the congruent symbol doesn't have the similar symbol doesn't have the equal underneath it. That would be congruent. These are similar. Same shape, different size. So then the ratio of the perimeters should be 3 to 2. So let's find the perimeters. Go ahead and do that. I'm not going to ask a question, but go ahead and get the perimeters of both of these. Okay, so I got 36 for this one, 24 to that one. If I wrote my scale factor, I still have to reduce it. I could write it as a fraction. 6 goes into both of these. I know that. So 6 goes into 36 6 times. 6 goes into 24 4 times. But then also 2 goes into those. So that means 12 went into both of these. And so 2 goes into 6 3 times. 2 goes into 4 2 times, which is the same. And so the ratio of the perimeters is the same. You can actually use the perimeters to get the scale factor if you don't have all the sides of one figure. That can help you find the perimeter of the other figure. Okay, number 4, pentagon CDFGH. Now I want you to notice how we're naming figures. You just start at a letter and you go around. So the pentagons are similar. And it says find the value of X and Y. So what we're going to do is we're going to find corresponding sides. So CH, first and last, goes with JN. So this is reflected, as you can tell. CD, first and second, go with JK. Kind of knew that. And then we've got the DF. DF, right here, DF corresponds with KL. All right, out of those 3 highlighted segments, which one have numbers on them? The yellows. So when I set this up, I'm going to go yellow over yellow, and I'm going to pick another color and put orange over orange or pink over pink. I'm actually going to have to do 2 problems. X is pink, so let's do that first. So I'm going to go left over right equals left over right. Orange over or yellow over yellow equals pink over pink. So that would be X over 2. Go ahead and cross multiply and work that out, please, and get the answer. Okay, so you should get 6x equals 18, cross multiply, and x equals 3. All right, to solve for y, we still have to use yellow and yellow, so I'm going to say 9 over 6 equals 6 over y, and cross multiply. Go ahead and get that answer for me as well. And you should have got y equals 4. We have our values for x and y, and we are done. Guys, this is similar figures. This is not hard. Okay? This is not hard. All right, next problem. The parallelograms are similar, so you can see how I have this written. Find the value of x, y, and z. So this is going to go back into our little bit of knowledge about parallelograms. What does angle M correspond to? Angle M corresponds to angle S. And so y equals 40. I'm not going to write it in the picture. I don't have room. This is a parallelogram. What is the measure of this angle right here? Next question. What is the measure of this angle right here from the last unit? It is a parallelogram. Those angles are supplementary because they are corresponding angles. Angle L corresponds to angle R. So Z equals 140. And then we're going to set up our proportions. I know because this is the longer side, it goes with the longer side. Shorter side goes with the shorter side. I'm just showing you that if you use colors, it really makes it pop out at you. Green over green equals yellow over yellow. Left over right equals left over right. Go ahead and cross multiply for that and get your answer for x. And you should have got x equals 6. Easy peasy. Okay, and so last question, go ahead and figure that out. Make sure that you match up the right pieces, make sure it's not turned or anything, and set up your proportion and solve. Okay, so did you make the mistake of highlighting this by looks, or did you follow the pattern of the similarity statement to match up the correct parts? If so, you got the wrong answer. So I looked at what DE went with, and I said DE corresponds to HJ, and I knew that DE, oh, there's a mistake. Okay, let's go back. DG goes with, this is out of order right here. This is a mistake. HJKL, DEFG. This piece should be over here because, let me just make sure, HL, no, I have it right. DE goes with HJ. DE goes with HJ. So this piece, actually, because it is a rectangle, it's not wrong what I have written down, but they're just being a little tricky with it. So DE corresponds with HJ, which is this piece over here, which is also this piece right here. So then I knew that DG went with HL, DG goes with HL. Okay, so then I put orange over orange equals yellow over yellow, cross multiplied, and I got the answer 26.6 repeating, or 26.7. Guys, you shouldn't have to pick up your calculator to do this. I want to show you how quickly you should be able to do this. If I asked you what the scale factor of this figure was, you can get the scale factor by putting the orange over orange. What does 27 over 18 reduce to? 27 over 18 reduces to 9 goes into 27 3 times, 9 goes into 27 2 times. When you have the scale factor, you can go ahead and reduce this fraction and use the scale factor and not have to pick up your calculator. 3x equals 80. Yeah, you probably might have to pick up your calculator if you wanted to get a quick answer for that, but that gives you the same answer of 26.7. Okay, and also I want to remind you that if I went right over left, right equals right over left, 18 over 27 equals x over 40, I get the same answer because I'm multiplying the means and extremes. If I were to ask you what is the perimeter of the smaller rectangle, then I would know that this is 26.7, 26.7 plus 18, I could get the scale factor very easily. Okay, we are done with the notes. Thank you, students, and I'll see you in class.